We'll proceed in vector and commercial calculus. Vector and commercial calculus. This is the topic that we are pursuing now. Vector and commercial calculus. So, vector and energy calculus. Vector, whenever vector comes into the picture, it symbolizes energy because energy has magnitude and energy has direction. Similarly, vector has magnitude and vector has direction. Okay, one thing. Second thing we talked about, if I have energy source, if I have energy source, then energy source will have a force vector. If earth is an energy source, this is a different way. If you see physics, then earth attracts everything. Earth is a mass. Every mass attracts other mass. And what is the attraction force is GMM. If there are two masses, they attract each other with GM. G is the some constant, M is mass of one object and another M is mass of another object divided by distance square. That is the force at which they attract each other. Okay, so that is the, I believe, gravitational theorem or something like that. So if Earth is a mass, it attracts something. If I have a mass, hup, hup, hup. Okay, so if I have a mass, if I have a mass and I have another mass, this mass is trying to attract this mass. If I have a mass, then this mass is trying to attract this mass. This is capital M and this is small m. That is the weight. This weight is capital M and this is small m. Then what is the attraction factor? Then attraction factor is Gm. If I consider this minus g is a some constant and m is its mass divided by the distance from which it is kept. Okay, what is the net force through which it is okay, so this is at what acceleration, it is attracting. Okay, if I talk about the acceleration, then minus gm divided by r square, that is the distance. What is the force through which this mass is getting attracted here? Whatever acceleration this is showing into this mass is the force through which this is getting attracted towards it. These are the Newton law. If I have a mass capital M, if I have a mass capital M, then this will show one kind of gravitational pull, gravitational acceleration towards itself. If there is a one guy here, so what is the gravitational acceleration it is placing in its environment? That is minus. Minus means towards itself. Vector minus g. G is some constant, not 9.8. Capital G, that is small g, minus g, and m is the mass of this, minus minus gm, minus gm divided by r to the power 3 r vector, minus gm r vector divided by r to the power 3. Okay, if that is the case, that is the acceleration it is passing. Now if I multiply acceleration with the mass into acceleration is the force. If this is it has a mass of small m, the acceleration that it is trying to impart around it is minus capital G capital M r vector divided by r to the power 3. Okay, what about this? If it is small m, whatever the acceleration it is showing, if I multiply by m, then that is the force through which it is getting attracted towards it. If this m is very high, then with more force it will get attracted towards it. If m is very small, then with less force it will get attracted towards it. These are called law of gravity. I mean, whatever the Mr. Newton is saying. There is another thing. This is what These are priceless videos. Okay, but when we come to vector manipulation, then we think Earth as not an entity, not a mass which attracts something, we consider Earth as energy source. This is different science at all. It has nothing to do with the Newton science. It is different science at all. Energy science. Now, in energy science, Earth is a Earth is an entity that is a kind of energy source. Similar to, like many times, I believe I have considered this is a capacitor. This is a cap. This is a capacitor. This is a capacitor. And if this is a capacitor, if I charge it, then once it is charged, it is as good as a battery. And if I place any LED bulb or something like that, that will glow. Means this starts behaving like an energy source. Similarly, Earth is an energy source. If Earth is an energy source, it will have a force field. Okay, like instead of considering if I consider this is a mass, then it has a force field. This is a mass, then it has a force field. Anything comes in the force field, it will start moving towards it. Means this is working now. Hup, 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 hup. This started working. It started losing energy, and because of its energy, the any mass comes into the vicinity of this bigger mass, it will start getting. So this is a smaller mass, and it is rotating somewhere. Okay, it is rotating somewhere. The acceleration it is pulling is minus gm by r square or minus gm r vector by r to the power 3. More you go in radial distance, this acceleration will decrease. Force that it is feeling because of this mass is acceleration into mass. That is whatever we get minus gm by r square into this m r square. If I go distance more and more, square 1 by a square, that much energy it will feel less. So if it at 10-meter distance, then the force whatever it is feeling, if from 10 it is at 1 meter distance, whatever the force it is feeling, if it goes 10 meter, 1 by 100 time it will feel less. That way force start getting decreased. Whatever it is, this energy source is there. If somehow it comes in its vicinity and start coming near to it, then this is working. This guy is working because something is coming near to it. Okay, then there is a work done. There is nothing free. If this mass is coming near to this mass is working. So if there is a work done is going on, then energy is getting pulled out from someone. This guy is losing the energy. Okay, and then this mass is getting attracted towards him. If I okay, if somehow after some time another mass comes into the picture and then it again gets pulled towards it. If it keeps happening, then this will be completely energyless. Okay, someone would say, why you are talking like this? Earth is never energyless. When I was born and whatever I am now, I always saw that Earth is at same energy. This proves that it is not a science of energy, it is science of gravitational pull only. And it is a mere gravitational pull. Every mass, Earth has a mass, right? If it is a mass, it will pull something. It has acceleration, and because of acceleration, any mass comes into the vicinity of the Earth, then there will be a force on it. And since there is a force on it, it will get attracted towards it. Then this is where is there energy? There is no energy here. Okay, it is simply a mass. If you grow in the mass, then acceleration will grow, force will grow, and it will get attracted. That's it. This is physics. Okay, but this is not mathematics. Certainly, Earth is energy source. Earth is not more than that. It is merely an energy source. If something is getting attracted, then the way you are saying, if 1 billion item comes into the vicinity of Earth and they get dropped on the Earth, but they will not damage the Earth, they will get dropped on the Earth, then Earth will lose complete energy. After that, it will not attract anyone. True. This proves that Earth keep getting energy from somewhere. Okay, there are energy that is beyond the physical science, physics science. Earth keep getting that energy. Sun keep getting that energy. Any star keep getting that energy. Any planet keep getting that energy. And that's how satellite get revolved around the planet, because planet is always energetic. Okay, these are mathematical science. Now we saw that there are two kind of energy source. One energy source is path independent. One energy source is path dependent. Okay, independent means if you move, if this energy source is path independent, if item is moving from here to here, how much energy it is losing? It is same as item is moving from here to here in a straight line, or in a circular line, or in a zigzag way, or in a stairway, in a parabolic way, whatever, doesn't matter. Begin point and end point only matter, that much energy it is losing. If one item is moving from here to here and coming back to here, then it is not losing any energy at all. If begin point and end point are same, it is as good as it did not move at all. In that sense, energy lost by the energy source is zero if it is path independent. Okay, if it is path dependent, then path matters. Not only the begin point and end, begin point, end point matter, path also matters. That is path dependent. Now we are in a technology to know that how much this energy source is path dependent. How much? Okay, for that people try to find out that if under a energy source that is path dependent, if I take an item moves in a closed loop, not in a circular loop. It starts from same location and come back to the same location. See how much energy this guy is losing because it is path dependent. Divide by the area it forms. If it is a closed loop, it forms one area. Divide by the area. Okay, then it is called whatever comes in the energy calculation divided by the area. It is also called circulation density. How much it is? Okay. Now, since everything is a vector, the energy calculation is different. Okay. If I say that if or something is moving around it, something is moving around it, coming to the same location. Something is moving like this. This is moving in XY plane. This is moving in XZ plane. This is moving in YZ plane. Okay, everywhere energy computation will be different because it is path dependent and direction dependent. This is what I would say. Okay, so if you keep changing the path orientation also, keeping the same area, if I am letting someone move in ellipse, and it is moving in XZ plane, it is moving in YZ plane, it is moving in XY plane in elliptical shape, then whatever the circulation density is, it would be different. The energy computation will be different. Area is same. Okay, so the energy computation in a closed loop divided by the area is called circulation density. When now someone would say you are saying that if I am moving in different direction, energy computation is different. Go in a direction where energy computation is maximum. Maximum energy is fetched from this energy source when an entity is moving in some direction in a closed loop. Then divide by the area. That is called circulation density. What is the direction of the circulation density? Whatever surface I am making perpendicular to the surface, if I draw a line, then that line direction is called the direction of the circulation density. Okay, what are the understandable, right? If it is moving in XY plane, then the line that comes XY plane means there is a surface on the XY plane. Now, if there is a line that comes perpendicular to the surface is the Z axis. Okay, then direction of the circular density, or someone can say circular density is found along the Z direction, because there we saw if means whatever plane we are talking, the plane in which the item is rotating, the plane in which this item is rotating. Okay, in that plane, if I kind of take the perpendicular to the plane, that is the line, that line is the direction of the rotation. That is the along that line we found the circulation density, in the sense there we saw it is maximum. Okay, what are the other way to find the so more circulation density means more the energy source is path dependent. What are the other way we found path dependency? Other way we found in the path dependency was through the Green's theorem. How much curling it can make. That is also one is circulation density. Circulation density is a measurement. If I say I have one energy, this kind of explanation is not there anywhere else. People just talk about vector, dot product, cross product, and this is the answer in this direction. That's it. No one matches it to real life. Okay, that's the difference. That's why we are here. Because we are finding that people are getting distracted from the mathematics because they don't see any use in their real life. People who are attracted toward mathematics because they have to pass examination and they have to get a job. That's it. Okay. So now it should be interesting. Now idea is there any other way I can find the how much path dependent it is? How much path dependent in the sense if I take if this is energy source and if this is one point and this is one point, if it is highly path dependent, then energy computation from this point and coming back to this point and coming back to this point, if I take one circular path, then how much is the energy computation is? If I take a straight line here to here, then back to here, how much is the energy computation? If I take another path, okay, depending on the path, the energy computation in a closed loop will be different. Okay, now if that is the case, then how much it is depend upon the path? If I take a straight line, then it is a shortest path from same point back to same point. If this is a point A and this is point alpha, then what is distance between A and alpha multiplied by 2? That much distance it is covering. But if I move in a circular direction, then radius is A minus alpha by 2. Then it will be 2 pi A minus alpha by 2. Pi into A minus alpha. And here it is A minus alpha into 2. Pi is more than 2. So distance covering is more. If I take bigger direction, so if I go bigger path, bigger path, then kind of energy computation will be more, even though it beginning point and end point is same. The way we are increasing the distance, coming back to the same point, the way energy computation is growing, then it is highly path dependent. It is path independent when it is moving from one position and coming back to the same position, then energy is zero. Now, in between that, there is a degree of path dependence. Okay, how to calculate the degree of path dependence is calculate the energy computation and divide by the area. Because if you grow in the size of the path, then energy computation will be more. We are trying to find out the nature of the energy source. If we are trying to find nature of the energy source rather than path, then whatever the energy is involved in a closed loop path, if it is bigger, energy computation is bigger. Then area is also bigger. Divide it by area. If it is small, energy computation is small. Divide by the smaller area. That will give the nature of the dependency path of the energy source that is path dependent. Other science is that if this has a force field, if this is the energy source, it has a force field. If it has a force field, then force field has component. Force is vector. It has component like a capital F is a force field. It has components like F1I plus F2J. Any vector has component along x-axis, y-axis, and z-axis. If there is a force vector because of this energy source, then there is a F1I plus F2J. If it is 3D, then F1I plus F2J plus F3K. Okay. Now, if there is a direction, then okay, consider this is one point and this is another point. Okay, there is a path like this. Now it is considered it is 2D. 2D means F1I plus F2J of the force field. F1 means in this direction. F2 means in this direction. If this F1, if I move this F1 along y-axis and it is not changing, everywhere F1 is same, then because of F1, if you see, it will try to push it like this. If F2 is there, here F2 is same and here F2 is same. F2 is not changing if I go along x-axis. It will try to push it like this. One will try to push it like this. One will try to push it like this. It will go somewhere in this direction, but it will not rotate. That is called curling factor, torque factor. How much it will rotate? It will not rotate. But if F1 is changing, if I go in Y direction, here F1 is less. Sorry, here F1 is more and here F1 is less. Then because of F1, it will try to rotate in this. It will move away also and it will rotate also. Okay, if there is F2, if there is F2 and F2 is changing, if I go in this direction, it will go in this direction in F2, but it will rotate also. Okay, if this, if rotation because of F1 is like this, if rotation because of F2 is like this, if they nullify each other, then there won't be any rotation at all. Okay, whatever is F1 and whatever is F2, because of that, the item would move. Consider this is a path, and there, I thought every time I would bring a bolt. Okay, okay, consider that there is a bolt. Consider I make a hole inside this. I make a hole inside this and then pierce it. It comes inside this. Since this is the path and there is a magnetic force like this, there is a force like this. Because of this force, this item will start moving in this direction because path is set in this. This is pierced inside this. So it will move inside this line only. And from here, it will go like this and it will come here, it will stick here. Okay, if that is like this, then this will not rotate. This will not rotate. It will just move like this because force 1 and force 2. If F1 is high, then this will move like this. F2 is high, it will again move like this only from here because path I have set like this. If I have set the path like this in a curved direction, and if I pierce this inside this, then it will move like in a curve only because this is the path I have set. If I set path as a circular, then it will move in a circular fashion. Okay, but it will not rotate if the if df2 df1 by d, if df, this is f1 and this is f2. Okay, if df1 by dy is there, it will try to rotate like this. Okay, it is completely right pen. Okay, it will try to rotate like this. How I can say? Okay, if there is a force field like this, okay, and df1 by dy is there, then it will try to rotate. It will move up because f1, it will move this side, but it will rotate also. Okay, if df2 by dx is there, it will move up and it will rotate also. Okay, if both are same, df1 by dy and df2 by dx is same, then it will go along the way force field is, but it won't rotate. Now it is considered that how much df2 by dx minus df1 by dy, df2 by dx minus df1 by dy is 0, then it is called curling factor is 0. The tendency of the energy source to make something rotate. Okay, what is the tendency of something to let it rotate? If this is the energy source and this is one item, it came in the gravitational pull of this item. Now it is moving towards it. While moving, it is rotating also. Moving towards it and it is rotating also. This shows that this energy field has rotation tendency. If it attracts someone, then it let that entity rotate also. Okay, Earth is not path dependent. The more it has tendency to make someone rotate, more it is path dependent. If it has no tendency to rotate, it is path independent. Earth has no tendency to rotate. You can same it will fall. It will not rotate. Okay, this proves that Earth gravitational force has no curl factor. More curl factor is there, more tendency to rotate. More tendency to rotate, more it is path dependent. This is another measure. One measurement of path dependence is circulation density. From if item is moving from same point and coming back to same point, it is making a closed loop. Closed loop area comes into the picture. What is the energy involved moving one place, coming back to same place? Area, energy involved, energy by area. That is the circulation density that talks about the path dependence nature of the energy source. Or what is the tendency of any force field to make any mass rotate when it pull towards it? These explanations are not available anywhere. Please do support us. +91 is the India country code 948316 610 is the telephone number. 9483160. 610 is the telephone number. 9 plus 91 is the India country code. Okay, now one factor to know how much it is path dependent is circulation density. Close get the energy involved in a closed loop divided by the area. This also talks about the nature of the energy source because once I divide by the area, the displacement direction is gone. Effect of displacement direction is gone. Or other is df2 by dx minus df1 by dy. Surprisingly, fortunately, both are same. Circulation density and curling factor both are same thing. Both are not different thing. Okay, if that is the case, then we will use some case. Now, I can say, can you calculate the curling if I have a energy source? Energy source is known by its force field. What is its force field? Through force, as I say, through eyes, through eye, through eye, you can know the energy source. So where is energy source? Brain is energy source. If you see the eye, then you can estimate how much energy that brain is carrying through the eye. Okay, eye reveals the energy source power. Similarly, the force field. Okay, I did not push it. It fell, but see the power of the earth. Earth, any mass power, the energy power of any mass is estimated through its force. With what force it is attracting, okay, or acceleration or gravitational pull, okay, what is meter by per second square, that is the acceleration. Or if you multiply by the mass of the item that is falling on it, then multiply by mass, then it becomes force. With what force it is pushed. Okay, if I multiply force into displacement, that much energy source lost. That much energy, the energy source lost because it made item move from this location to this location. Okay, now I know that if I know the curling factor df2 by dx minus df1 by dy, then I can say that my energy source is how much path dependent. Okay, or or if I find circulation density in a closed loop, if I find the energy involved and divide by the area of the closed loop, then also I can find what is the nature, how much the energy source is path dependent. Can someone talk about how much earth is path dependent? Okay, tell me the earth gravitational force. Force is a force symbolizes the nature of the energy, not only the power of the energy source, but nature of the energy source also. So earth gravitational pull is minus g, one constant, mass of the earth r vector divided by r to the power 3. R vector divided by r to the power 3. Okay, then someone can calculate it. How much how much is the gravitational pull of the earth? Okay, if that is the case, then the gravitational pull minus gm constant. Now it is df2 by, okay, it is three dimensional. What is the curl factor in this? Two dimensional we learned df2 by dx minus df1 by dy. Okay, that is in 2D. So if I am moving an item from here to here, I can divide it into small section and every section is a straight line. This is so small it can be considered as a straight line. Then in that straight line section, I get df2 by dx that would rotate it like this and df1 by dy that would rotate it like this. If I subtract it df2 by dx minus df1 by dy, that is the net rotation tendency at that point, okay, as per the algebra at that point. But the rotation, if rotation happens for a kind of, if this item is rotating, if this item is rotating, this is xz plane, this is y, this is x axis, this is y axis, and this is z axis, x axis, y axis, and z axis. Okay, if this is rotating like this is rotating in xz plane, this is rotating in yz plane, this is rotating in xy plane. If it is rotating in xz plane, this rotation has a surface. This surface is looking toward this axis. So this rotation, whatever I'm rotation should happen in kind of anti-clockwise. If this is the rotation in xz plane, then this is the axis. This is rotating along y-axis. If I take, if I rotate like this, it is same as if I pierce it and then rotate it in a anti-clockwise direction. Same thing it will rotate. So it is rotating. The rotation direction is y-axis. If I rotating something in xy plane, it is same thing is if I pierce it like this and start rotating like this, then it is rotating along the z axis. Okay, then if I say df2 by dx minus df1 by dy xy, it is in xy plane. The rotation is happening along the k direction. Df2 by, actually full term is df2 by dx minus df1 by dy k vector. If I want, this is the rotation along k axis. If I want to see rotation along y axis, then it is, item is moving in xz plane. Df3 by dx minus df1 by dz, that will come into the picture, that will be along y direction. Minus plus equal settled down. Now if someone is seeing how much is it along the x direction, then it has to rotate in yz plane, then it will be in x direction. df df3 by df3 by dy minus df2 by dz, that will be in I direction. How much, tell me how much net in any direction, then altogether you have to sum up. Then it is df3 by dy minus df2 by dz in I direction. Okay, plus one vector, plus, okay, df1 by dz minus df3 by dx in j direction, plus df2 by dx minus df1 by dy in k direction. This is the net curling factor vector will come into the picture, where magnitude of this will be the magnitude of rotation, and whatever ijk net vector direction is, that is the direction of the, that is direction of the curling. So if there is a force vector like this, if there is a force vector like this, and then force vector has component f1i plus f2j plus f3k. If I say df3 by df3 by dy minus d df1 by df3 by dy minus df2 by dz I vector plus d minus plus equal settled down, plus df1 d, okay, plus df1 by df3 by dx minus df1 by dz in j direction, j vector, plus df2 by dx minus df1 by dy in k direction. Whatever the direction net, if you solve it, it will come in algebraic form. Okay, it comes in algebraic form, and you replace x, y, z at any point. At that point, what is the direction of the curling? What is the direction of the curling? I say direction of my curling is I plus j plus k. This is what I found at point 1 comma 1 comma 1. If this is x axis, this is y axis, this is z axis, this is origin, then this is 1 comma 1 somewhere. There I found my curling vector is I plus j plus k. Means I plus j plus k, whatever vector is there, exactly perpendicular to it, make the surface. The surface and this vector should be exactly perpendicular to it. So curling will happen in this direction. If there is a mass like this and item is moving like this, whatever direction I showed now, it will rotate in that direction, in that plane. Okay. If curling is happening in xz plane, if mass is there, then this will rotate in xz plane. If curling is happening in yz plane, I'm sorry, if curling is happening, the direction of the curve is y vector, then perpendicular to the y vector is xz plane. The item would move like this when it is going towards it. It will keep moving like this. If curve vector is like this, then curve vector is like this, then item would move in xy plane while going towards the energy source, like that. Okay, so I believe this is 3D. People tried finding easier in 3D like a matrix. First row of matrix say I plus j plus k. Sorry, I, j, k. First row of the matrix is I, j and k. Next row of the matrix is the gradient vector, that is d by dx, d by dy and d by dz. Third row is f1, f2, f3. Now get the first determinant, that is in I direction. Then it will become d df2 by dz minus df3 by dy. Okay, minus j. Next, minus j. Next, df1 by dz minus df3 by dx, or plus j df3 by dx minus df1 by dz. Now k direction. Okay, df2 by dx minus df1 by dy. Same thing. Now this way you can get the curling rotation vector. If you get curling rotation vector, the surface will be exactly perpendicular to this vector, and there in that direction the item would start moving. If this is the item, it will move exactly along like this in surface. Okay, where the curl vector what we found will be exactly perpendicular to it. Okay, this tendency, the curl tendency, talks about the path dependence nature of the energy source. Now, Earth is path dependent or not, that we will calculate. The Earth force vector is minus capital G m, that is the mass of the Earth, and then r vector is the vector towards it, minus it is attracting towards it, direction is towards it. R vector, that is towards it, divided by r to the power 3. This can be a homework or assignment someone can try. It's easy, right? Now I know that it is, if it is 3D, now it has F1, F2, F3. If this is the force field, it has F1, F2, F3. F1 is minus GMX. R vector, I can say xi plus yj plus zk. Minus GMX minus gmx divided by r to the power 3, x square plus y square plus z square to the power 3 by 2. This is f1. F2 is minus gmy divided by x square plus y square plus z square to the power 3 by 2. Okay, F3 is minus gmz divided by x square plus y square plus z square to the power 3 by 2. Now someone can find out whatever we said in 3D area, where it is df3 by dy minus df2 by dz I vector, similarly j vector, similarly k vector. Now settle it down with the f1, f2, f3 and see if it becomes 0 or not. Okay, let's try the k vector, that is, I believe that is easy, df2 by dx minus df1 by dy. Okay, someone can try it. Okay, it will be long computation. We will do it. So df2 by df2 by dx. Okay, df2 is minus y minus gm. Okay, minus gm y by x square plus y square plus z square divided by 3 by 2. Minus gm, I can kick it out. Minus gm completely. It's a constant. Now it is y by a square x square plus y square plus z square to the power 3 by 2 by dx minus df1 by dy. F1 is x by x square plus y square plus z square to the power 3 by 2 by dy. Okay, if someone compute it, first term it will become 0, and then y into, I believe it will come as uh, y square or something like that, and that side again, and then settle down. Try, someone can try. Okay, I'll also try. Okay, and it should become 0 because it is path independent. If someone proves it that curling factor is 0, then it is path independent. We'll take more example into circular fashion only. This is circular example. We take circular example in the sense because at the end we land up in the circulation density, that is in a closed loop. Okay, so or we can try x by, what is, if I do f2, f2 is y by something like that. If I derive it with y, if I derive with x, okay, derive multiplying the kind of differentiating y by x square plus y square plus z square to the power 3 by 2. First I'll differentiate with x, that is why it is too big. Okay, I believe it will take a lot of time. Okay, so someone can try, and then he can kind of send here the answer, or you can just comment it. Okay, so plus 91 is the India country code, and 9483160610 is the telephone number. +9483160610 is the telephone number, +91 is the India country code. The channel description has email address also in which you can send the answer. You can just write it down in a paper and just take a photograph and you can send it. So that is more than enough. No need to type anywhere or something like that. Okay, so that we will see.